Welcome to today's deep dive. We are jumping into a really fascinating piece today from tech-reader.blog called JSON in 3 minutes.
Yeah, written by Aaron Rose. He's a software engineer and technology writer.
Right, and our mission for this deep dive is actually, well, it's pretty ambitious. We're going to completely demystify a crucial piece of modern internet infrastructure.
Which is much needed, honestly.
Seriously, because it's something that looks incredibly intimidating, but it's surprisingly simple to understand once you know what you are looking at.
Exactly. It's all about just shifting your perspective.
Yeah. And the reason we are tackling this is because if you spend enough time around modern technology, you're going to encounter it.
Oh, it's inevitable.
Right. Like maybe you found yourself poking around the advanced settings of a web app, or you accidentally hit a key and opened the developer tools in your browser.
Everybody's done that at least once.
Right. And if you have, you've probably experienced that very specific moment of panic. You're suddenly staring at this massive wall of text.
Just completely filled with like indented lines, quotation marks, curly braces.
Square brackets, yeah. And your immediate instinct is, oh no, I've broken into the mainframe. I am looking at raw computer code, and I need to back away slowly before I delete the internet.
It really does trigger that fight or flight response, especially if you don't write software for a living.
Absolutely.
You see that structured formatting, the bizarre punctuation, and your brain immediately categorizes it as a highly technical programming language, something that takes years of study to decode.
Right. But Rose's piece, it strips away that anxiety almost immediately.
It really does. It's a great read for that exact reason.
Because the very first thing we have to do here is, well, we have to shatter that illusion entirely. That wall of text we were talking about, it isn't code.
Not at all.
At all. Not even a little bit. It is something called JSON.
Which, to be fair, part of the problem is the name itself.
Well, 100%.
Yeah.
JSON stands for JavaScript Object Notation.
Right.
Which, frankly, sounds exactly like a programming language.
The name is definitely a hurdle. I mean, it literally has JavaScript in it. But what we need to focus on is the core definition.
Okay, let's hear it.
JSON is simply a lightweight format for storing and exchanging data. That is all it is.
Okay.
It's not a set of instructions telling a computer what to do. It's not a script. It doesn't run or execute.
So it's strictly a data format.
Exactly. It is just a highly organized way to package information so it can be passed around between different systems.
Okay, so if it's not code, what is a good mental model for it? Because staring at it, it still looks like a wall of data.
Yeah, it can be dense.
How should we be visualizing this?
Think about the last time you went to a new doctor's office.
Oh, I hate filling out those forms.
Right. You walk up to the receptionist and they hand you a paper intake sheet on a clipboard.
Yeah, the one with all the little boxes.
Exactly. That paper form has printed boxes on it. One box says first name with a blank line next to it. Another says date of birth with a blank line.
Right, okay.
That is essentially what JSON is doing, but in a digital format. It relies on something called a key-value pair.
Wait, okay, so the printed label on the paper, form like first name, that is the key.
You got it.
And whatever I write into the blank space like John, that is the value.
That's it. Every single piece of information in JSON is structured exactly like that.
Wow, okay.
You have the label, which is the key, and you have the data itself, which is the value.
That's surprisingly simple.
Right. But what's really crucial to understand is why we have to do it this way. I mean, why not just write out sentences?
Yeah, actually, why not? Like, if I want to pass data around, why can't this system just send a message saying the patient's name is John and his date of birth is today?
Because computers are terrible at nuance.
Oh, right.
Think about reading a standard paragraph of English text. A computer has to work incredibly hard to figure out what a sentence actually means.
It's not like a human brain.
Exactly. It has to parse the grammar, extract the noun, locate the verb, understand the context.
And hope there isn't any sarcasm or weird phrasing.
Precisely. It requires really complex natural language processing. But with the key-value pair, the computer doesn't have to guess.
Because it's explicitly labeled.
Right. The key explicitly tells the computer what the value represents. There is zero ambiguity.
Oh, I love that.
By separating the label from the data, you just strip away the need for complex programming logic just to read a document.
That makes a lot of sense. It basically takes the guesswork completely out of the equation.
Exactly.
First name is the key. John is the value. The computer doesn't need to understand English grammar. It just, looks at the label on the box.
Just reads the form.
So if JSON is essentially just a perfectly organized digital intake form, the next logical question is, Well, why did this specific format take over?
That's the million-dollar question.
Because Rose points out that JSON is everywhere. Web applications, AWS cloud services, AI platforms, mobile apps. I mean, it's ubiquitous.
It is the absolute backbone of modern data exchange. And the reason it won out over other formats is that it hits a very rare, very specific sweet spot.
What kind of sweet spot?
It has a dual advantage. Humans can read it easily, and computers can process it easily.
Which usually isn't the case, right?
Rarely.
Because usually, things that are highly optimized for machines just look like complete gibberish to a human.
Exactly.
And things that are easy for humans to read, like, say, a novel, are a nightmare for a computer to process accurately.
Right. That's the historical tension in computer science. You have two completely opposite consumers of information.
Okay, break that down for me.
Well, on one hand, you have the human engineer who needs to see the data, troubleshoot it, and, quickly understand what is going wrong if an app crashes.
Right, they need to actually be able to read the screen.
Exactly. On the other hand, you have the computer processor, which just needs structured data. It can parse in milliseconds without getting confused.
And JSON does both.
JSON manages to satisfy both. It uses standard text and visible formatting so human eyes can scan it, but it relies on strict, predictable rules, those key value pairs, so computers can process it instantly.
It's like it acts as the ultimate Rosetta Stone of the internet.
That's a perfect way to put it.
I want to dig into that Rosetta Stone idea, because it's not just translating between humans and machines, is it? It also translates between wildly different computer systems.
Yes, and that is where its real power lies.
Okay.
Look at the landscape of technology today. You might have an AI tool built on Python running on a massive cloud architecture.
Right.
And you might have a mobile app built on a totally different language running on your iOS or Android device.
So they're completely different under the hood.
Right. Historically, getting these distinct systems to talk to each other was incredibly difficult because they spoke entirely different internal languages.
So they couldn't just hand data directly to each other.
No, they would essentially be speaking Greek and Mandarin.
Oh, wow.
But JSON steps in as the universally agreed upon neutral messenger.
I see.
If that AI tool needs to send data to your smartphone app, it doesn't try to speak the smartphone's language. It just wraps the data up in JSON.
And the phone knows what to do with that.
Exactly. The AI knows how to write a JSON document, and your phone knows how to read a JSON document.
So they don't need to understand each other's internal logic. They just both need to understand the messenger.
Exactly. It's a universal standard.
That is such a brilliant solution.
Yeah.
It creates a neutral territory where, like, every piece of software can meet to swap information.
Yeah, it really changed everything.
But I want to pull us out of the theory for a second and get practical.
Sure.
Knowing JSON is a universal messenger is great. But if we want to empower you, the listener, to actually look at this stuff without your eyes glazing over, we have to talk about the punctuation.
Oh, the punctuation, yes.
Because as much as we say it's just an intake form, it is absolutely covered in brackets and curly braces.
It really is.
And that punctuation is exactly what makes people freeze up.
Oh, it is entirely normal to feel overwhelmed by it. When data is wrapped in symbols, it just looks aggressive to the human eye.
It looks like math.
Right.
Yeah.
But the piece breaks this down into two major structural concepts.
Okay.
Once you understand these two specific tools, you can decode how JSON handles really complex, multi-layered information. We need to talk about arrays and objects.
Okay, arrays and objects. Let's start with arrays. The piece says an array is indicated by square brackets.
Right, the straight, sharp corners, open bracket, closed bracket.
And it defines an array simply as an ordered list of things, just multiple values grouped together.
Yes. Think of an array as a simple grocery list.
Okay, I'm following.
If you have a key called groceries, the value attached to that key isn't just one thing, it's the whole list. Apples, bananas, milk.
Right.
All of those items are grouped together inside those square brackets. It's just a way for JSON to say, hey, the specific label has several answers attached to it.
Okay, so an array is a list in square brackets. That is pretty straightforward.
It is.
But the second structure, objects, seems a bit heavier. The piece notes that objects are indicated by curly braces.
The squiggly ones, yeah.
And this is where JSON allows for nested information.
Right. Objects are where JSON really gets its superpower. An object is a way to group related key value pairs together.
So how does that work in practice?
Well, to use a physical analogy, if an array is a flat grocery list, An object is more like a physical filing cabinet folder.
Oh, I like that.
You open the folder, and inside you find a collection of documents, the key value pairs, that all relate to a single topic.
Okay, so if I have an object for a user, inside those curly braces, I might find keys for name, email, and age.
Exactly. But here is the critical part. Objects can contain other objects. You can nest them.
Wait, what?
So you open that main filing cabinet folder for the user, and inside, along with their name and age, you might find a smaller labeled subfolder called address.
Okay.
And when you open that subfolder, you find keys for street, city, and zip code.
Wait, let me clarify that. A folder inside a folder. If we were just trying to pass data around, doesn't nesting folders inside of folders get unnecessarily messy?
It might seem like it at first.
Why not just list user street and user city in the main folder and keep it totally flat?
Because real-world data is rarely flat. Think about a complicated system like an e-commerce order.
Okay.
One order might have a customer. That customer has a billing address and a shipping address. The order also has a list of items, an array.
Oh, I see where this is going.
Right. Each item in that array is an object with its own price, size, and color.
That's a lot of data.
If you tried to write all of that out in a flat list without subfolders, the labels would have to be incredibly long and repetitive. And the computer would really struggle to understand how the data relates to itself.
Ah, I see. So by using nested objects, you group the context together. The city belongs to the shipping address, which belongs to the customer.
Yes, it creates a hierarchy. And I really encourage you to look at the absolute brilliance in this simplicity.
It is pretty elegant.
We are literally talking about two things. Lists. The arrays and nested folders. The objects.
Right.
By combining just those two incredibly basic concepts, this simple text format scales up to handle massive, multi-layered data architectures.
That's wild.
It can represent something as simple as your username or something as staggeringly complex as the entire configuration state of a global cloud server network.
Just by stacking lists and folders inside of each other.
Exactly.
Let's put this into practice. Aaron Rose gives us a concrete, real-world example in the piece to solidify this mental model.
It's a great example, too.
Let's walk through it, because I think it proves that anyone listening can actually read JSON right now.
Yeah, he asks us to look at an API and application programming interface that returns weather information to your device.
Okay, let's picture this. You open the weather app on your smartphone. Your phone sends a request to a weather services server somewhere out there, essentially asking, what is the weather in Chicago right now?
Right, and the server calculates the answer, and then it has to send that data back to your phone.
And it sends it back as JSON.
Exactly. The JSON acts as the messenger. So let's imagine the payload your phone receives. You'll see a big set of outer curly braces, the main folder.
Okay.
Inside, you scan the text, and you might see a key that says city with a value of Chicago.
Simple enough. Key and value.
Then you might see a key called current conditions. But the value next to it isn't a single word. The value is an opening curly brace.
Okay, so that means current conditions is a nested object. It's a subfolder.
Right, so you mentally step inside that subfolder. Inside those inner curly braces, you find new keys. Temperature with a value of 72. Sky with a value of sunny.
Nice day in Chicago.
Seriously.
Yeah.
Then you see a closing curly brace. You've just stepped out of that subfolder.
And then right below that, maybe there's a key called hourly forecast. And the value next to that is a square bracket.
Yeah, what does that mean?
So I know immediately that hourly forecast is an array. It's a list. And inside those brackets, I just see a list of temperatures for the next few hours.
See, you are reading JSON. You are unpacking the data exactly the way your phone does, just a bit slower.
That actually makes total sense.
Your phone receives that JSON payload, instantly parses the keys, the objects, and the arrays, and then translates that structured data into the nice graphics of a sun or a rain cloud on your screen.
If we were actually looking at this raw data on a screen, the piece outlines a very specific four-step reading strategy.
Yeah, it's essentially a toolkit for reading JSON quickly without getting overwhelmed by all the formatting.
Let's break down the 4 steps.
It is a highly practical framework. Step 1, look for the keys. Scan the document for the labels on the left side of the colons.
Okay. Step 2, read the corresponding values. What data is actually attached to that label?
Right. Step 3, ignore the braces at first. Pretend the structural punctuation isn't there.
And step 4, focus on the information being conveyed. But hold on, I have to push back on step 3.
Uh-oh.
Ignore the braces. We literally just spent 10 minutes establishing that the curly braces are what create the object.
That is true.
They define the boundaries of the nested folders. If I just ignore the braces, aren't I going to misread where one folder ends and another begins? That seems like terrible advice.
Okay, that is a very fair point, and it highlights the difference between how a human reads and how a machine reads.
Okay, how so?
For a computer, ignoring the braces is fatal. If a computer misses a single curly brace, or even a comma separating two items, the entire parsing process breaks down.
It just fails.
Completely. The file becomes unreadable to the machine. The syntax is incredibly fragile.
Right.
But for you, the human, trying to quickly understand what a JSON file is doing, the exact boundaries of the folders are secondary to the data itself.
Oh, I see, because my brain can use context clues that the computer doesn't have.
Precisely. If you are a human scanning a wall of JSON just to find out what the temperature in Chicago is, the braces are structural noise.
They just get in the way of what I'm looking for.
Exactly. The piece explicitly points this out as a common mistake new users make. They stare at the curly braces and the brackets and they panic about the structure.
Yeah, they get stuck on the punctuation.
This four-step rule forces a mindset shift. It changes your internal monologue from, I need to understand this complex code structure, to, I just need to scan this text for the key called temperature.
That does make it incredibly empowering. You stop seeing the braces as scary coding symbols, and you just let them blur into the background while you hunt for the labels.
Exactly. You focus on the content, not the container.
And the piece notes that if you do this, the structure becomes familiar organically.
It does. You start noticing the patterns without stressing over them.
Right.
Understanding that JSON is simply organized information is a paradigm shift. It demystifies the back end of the web.
It really does. You realize it isn't magic. It's just properly labeled data moving back and forth between machines.
Exactly. And having that mental model pays huge dividends across the tech landscape.
Whether you are trying to understand how an API works or why an app isn't loading data correctly. It's like suddenly being able to read the matrix, but finding out the matrix is actually just a really well-organized system of filing cabinets.
That is the best analogy for it.
So let's recap the journey we've taken today. We started with an intimidating code-like wall of text that makes most people immediately close their browser window.
Which is totally understandable.
But we shattered the illusion that it was a complex programming language.
We established that JSON is strictly a lightweight data format built on simple key-value pairs.
We look at it as a digital paper form, a doctor's intake sheet where you just fill in the blanks.
Right.
We explored why that strict labeling is necessary for computers that struggle with the nuance of human language.
We saw how it acts as the ultimate universal messenger, allowing completely different computer architectures to communicate smoothly.
Because it is perfectly balanced, readable by humans,
Yeah.
and easily processable by machines.
And we decoded the punctuation, revealing how square brackets create arrays, which are just simple lists.
And how curly braces create objects, which are nested folders capable of organizing highly complex, multi-layered data.
Exactly.
And finally, we armed you with a strategy to read any JSON file by shifting your mindset. Focus on the keys and the values, and let the structural braces fade into the background.
Yes. By understanding these core building blocks, you now know exactly how the invisible messenger of the modern internet operates.
It really provides a phenomenal foundation for understanding how our digital world connects.
It truly does.
But before we wrap up this deep dive, there's one final thought I want to leave you with.
Okay, let's hear it.
Something that builds on the realities of the modern tech landscape. Throughout this discussion, we talked about JSON's massive success, coming from the fact that it is the perfect compromise.
Right, it bridges the gap.
It is human readable, and it is machine processable. But the source material also pointed out that AI tools currently use JSON heavily to exchange data.
Oh, they rely on it extensively. When large language models call out to external tools or retrieve information, they are constantly generating and parsing JSON payloads.
Right. Now project that into the future. Imagine a near future where AI systems are not just using data, but writing, reading, and exchanging these data payloads at absolute light speed.
Interacting entirely with other AI systems.
Trillions of operations a second, with zero human intervention. What happens to our perfect compromise? Will that balance inevitably shift?
Wow, it is a valid question. Because the human-readable elements of JSON, the explicit text labels, the formatting, the spaces, they take up bytes.
Right.
They require processing power, however small.
Exactly. If machines are only talking to machines a million times a second, will we eventually need a new, purely machine-optimized format?
Something totally illegible to us, but incredibly fast for them.
Dropping the human readability altogether for the sake of sheer efficiency?
It's definitely possible.
Or will human oversight always demand that the readable Rosetta Stone of JSON remains the standard?
That's the other side of it.
Will we insist on keeping the data legible, just so we can step in, read the intake forms, and check the machine's work?
It really makes you wonder how long the simple digital form can maintain its rule over the internet.
As systems become more autonomous, the tension between human legibility and machine efficiency is only going to grow.
It will be fascinating to see which priority wins out.
It really will. Keep that in mind the next time you peek under the hood of a web app and see those curly braces staring back at you. You aren't just looking at code. You are looking at the delicate balance between us and the machines. Thanks for joining us on this deep dive. We'll catch you next time.